Hello to the ontological engineering class and anyone else who may be listening. This is my final project, and I will be going over quantum level waves in basic formal ontology. Basically, how do we represent them? There's no consensus on this, and I am going to argue for one possibility. The larger problem uh, to situate this is how should waves in general be represented in basic formal ontology. This is something that there's not yet much of a consensus on. Are they dependent continuants, such as dispositions? Are they continuant? Are they processes? Each of these has been an attempted answer within bioontologies and other ontologies, and there's no consensus for how to represent them yet. An even further problem is quantum level waves, because they are in many ways different from these classical waves, and there's a question, which I will answer in the affirmative, that they should be categorized the same as other waves. Well, they should not be categorized in the same as other waves. So here's some examples. I know they're difficult to see, but these are just two ontologies that have attempted to categorize wave phenomena. One of them puts waves as a process, as a biological process, because it's brain waves. This is the one on the left. The one on the right is actually a non-basic formal ontology, and they put it under dynamical entity, which I suppose might be a dependent continuant. Classical waves always have a material medium, such as water or air or the Earth's crust in the case of, say, an earthquake. And these waves cannot be identified with their medium, partly because the medium already pre-exists the wave, and partly for other reasons. The medium does not move with the wave. It moves in. If you've ever seen those pictures of water waves, an actual molecule of water will actually move in a circle while the wave moves in one particular direction. Also, what is being transmitted is not simply a shape. We want to say more than that. There's at least some energy and other things that make up the wave, and part of that, as we'll see in later slides, is dispositional accounts are inadequate. So what other possibilities are there? And here's a water wave. Throw a rock in a pond, and the waves will move outward, fairly standard. So Batchelor and Hastings' view is waves as processes. So an occurrent, a sort of complex occurrent, so dispositions play a part in this. For an example, a musical instrument will have a disposition to vibrate at a certain frequency. Um, but this disposition exists when the instrument is not being played. When you play the instrument, you activate this disposition, and therefore you're activating a current. So waves are affected by dispositions, but they are not themselves disposition. So if we look at a violin, each string has a particular disposition to vibrate in a certain way. This can be changed by your fingering and by other ways. But when you pluck the string, it will vibrate in a certain way and thus create a dependable sound each time. But with the violin, both the sound wave and the wave it creates has a medium. The wave that creates it, rather. Light waves are an example of waves that exist without a medium. Classical waves cannot be identified with their mediums, however, this is a little more complicated in the case of waves at the quantum level, like light waves. Perhaps these require a different description in BFO than classical waves do. So Batchelor and Hastings suggest that quantum level waves participate in their own processes. So you have the particle, it participates in a wave process, and that is what we call or that is the basis of the quantum phenomena. So waves at the quantum level do not have a medium, as we've said. The particles make up with them are material continuants, but this is not a straightforward wave. It seems to be intrinsically connected with the particle in some way, and although it's described mathematically in the same way as classical waves, what that description realizes is a probability that a particle will be detected somewhere. So this raises some objections to the view of quantum level waves as processes. First is that they seem to be continuous in some way. Whenever the subatomic particle exists, photon, or electron, or any subatomic particle, the associated wave also exists. So they seem to be permanent on some level, and the dual nature of quantum phenomena, as we'll get into, complicates this further. So then the famous double slit experiment will give us more evidence toward how to categorize these things. In case you are not familiar, the double slit experiment is a famous experiment within quantum mechanics. The setup is rather simple. First, you have a detection screen. Second, you have a screen with two slits in them that the screen itself is not porous with the things you're sending through. And third, you have some sort of gun or launcher. You can think of it in a way like having a tennis ball machine between two slits and a wall at the other side, if you crank up the tennis ball machine high enough, the where the balls hit is going to correspond to where the slits are um, in the second wall. So it's anything else will just hit the wall and bounce off. So assuming that particles act like classical particles, they should act like the tennis balls, and you should simply have two slits when you perform this experiment on particles. However, instead we get an interference pattern based on waves, which would be the same thing if you perform the experiment with, say, water waves. When we slow down the stream, this experiment shows that whether we're talking about light or electrons, the interference pattern still holds. So even though the photons or the electrons are coming one at a time, at the detection screen, they are still creating this interference pattern and not simply coming where you would expect them, lining up with the two slits. Okay, so let's dig in deeper to this. These particles are detected according to the wave pattern. However, they are detected one by one. It's not sort of as a single wave. The wave pattern determines the probability and possibility of detection at a particular location. This, to me, says that we're dealing not with processes, but with dispositions. Heisenberg, in Physics and Philosophy, likens these quantum level waves to Aristotelian potentia. These waves determine, among other things, the range of possible measurements, probabilities of where you detect the particle, etc. They are not like classical waves in this and other ways. And so for this reason, I submit that though the process view seems to work with classical waves, it seems that instead quantum level waves are dependent continuants and specifically dispositions. All right, thank you.